Hi everyone, welcome to this live session by Simplilearn. Today we are going to talk about some of the essential programming interview questions for a data scientist role. Now, since Python is widely used programming language for data science, machine learning and deep learning, we will be solving our problems in the Python programming language using Jupyter Notebook. So let's wait for a few minutes for people to join in. Also, if you haven't subscribed to our channel yet, then please make sure to subscribe to it now and stay updated with all the recent trending technologies. And if you want to get the code file that we will use in this session, then please put your email IDs in the chat section of the video. Our team will share the interactive IPython notebook with you. So let's begin with our first question. Our first question is, how do you get a list of all the keys in a dictionary? Now in Python for data science, data structures play an important role to store and manipulate data. Dictionary is one such data structure that is declared using curly braces, and they are written as key value pairs. You can see on the screen I have my dictionary called D, and it is assigned using curly braces. Now to get a list of all the keys in a dictionary, we use the .keys function. Now let me take you to my Jupyter Notebook. So here is my Jupyter Notebook, and you can see my first cell. I have my dictionary defined. So the name of the dictionary is D, and it has the key values. The keys are the country names and the values are the capitals of each country. So I have India and the capital is New Delhi. Then I have USA, the capital is Washington. Similarly, I have Spain, Madrid, and we have Germany and Berlin. Now India, USA, France, Spain, all these are my keys. So to get the keys, I'll use the .keys function. So I'll write my dictionary name, that is D dot, I'll give keys, close the brackets and hit Shift Enter. You can see these are the list of my keys in the dictionary D. Alright. Okay. Now let's move to our next question. So our next question is, what do you mean by list comprehension in Python? So list comprehensions are a short and easy way to define and create new lists based on existing lists. So suppose you want to iterate through a list and find all the even numbers in the list. You can either use a for loop and an if condition as shown here, or you can write a list comprehension to do it in one line of code. You can see this is my list comprehension. So let me show you both the ways. Alright, so here on my Jupyter Notebook, let me declare my list as L equal to, I'll pass in a few numbers, let's say 5, 12, 10, we have 14, 43, 11, 7, 9, and let's say the last element in the list is 6. Alright, let me run this list. Okay, now let me create an empty list. Let's say list 1, and let this be an empty list with square brackets. Then I'll use the looping construct to find the even elements in the list. So I'll write a for loop called for item in my list L. I'll give colon, then I'll give my condition if item percentage 2 is equal to 0, which means if the remainder is 0, then I'll append the items to my empty list, which is list 1. So I'll write list1 dot append, and I'll pass in the argument my item. Now let me go ahead and print my list. I'll write print the final list using a for loop. I'll give colon, give a comma, and pass in my new list name, which is list1. Now let's run this. You can see using this for loop and the if condition, I have got all the even elements in my list, which was L. You can see my original list, and 12, 10, 14 and 6 were all the even numbers present in my list. Now this task you can do it using list comprehensions as well. So let me show you how to do that. So I have my list defined. Let me just copy this here. I'll paste it, and now I'll create another variable which is list1. I'll write equal to. Now here, using square brackets, I'll write item for item in L, and I'll give my if condition as if item %2 is equal to 0, then I'll print my resultant list. So I'll write print, let's say, resultant list using list comprehension. I'll give a colon, then a comma, and I'll pass in my new list, which is list1. So here, whatever is there in my square brackets is called the list comprehension technique. Let me just print this, and I'll get the same result. So these are my even numbers. Alright, so let's move to the third question. So our third question is, given a list of numbers, find the squares of the numbers using the map function in Python. Now the map function calls the specified function for each element of an iterable and returns a result. So let me show you an example to find out squares of a list of numbers using the map function. Okay, so let's first define a function called square. So I'm using my def keyword, and I'll pass in my user defined function name as square, and I'll give my parameter as x, and I want to return the square of x, which is x star x. Alright, and then let me define my list of numbers. So I'll pass in a variable called num, and let's say I want to find the squares of 5 numbers 1, 2, 3, 4, 5. Here I'll pass in another variable which will store the resultant list. So I'll write num underscore squared equal to, here I'll use my map function. So map function takes in two parameters. First it will take in the user defined function name, which is square here, and the list of numbers, which is num. I'll run a for loop. I'll write for, let me just scroll down. I'll write for num in num underscore squared print num. So this is my map function. So it will map all the elements in the list to this function, which is square. I'll just print it. You can see we have the list of squares from the num list, which has the elements 1, 2, 3, 4 and 5. Now moving ahead, coming to our fourth question. The fourth question is on to write a program that will filter out the numbers divisible by 3 from a tuple using the lambda functions. So lambda functions are anonymous functions that are not defined by the def keyword in Python. So here you can see I have the example. So this is a tuple I have defined, and using filter along with the lambda function I am trying to find out the numbers that are divisible by 3, and finally I am printing those numbers. So let's do it on our Jupyter notebook. Alright, so we are on the Jupyter notebook. So first I'll define a tuple. Let's say the variable name is my underscore tup, which stands for my tuple, and using brackets I'll pass in my tuple values. Let's say 5, 12, 10, 18, we have 43, 9, 7, 11, and let's say 6. So you can see these are the numbers present in my tuple. Now I'll create another variable called new tuple, and I'll use my tuple function, and inside the tuple function I'll use the filter function that will filter out only the values that are divisible by 3. And now I'll write my lambda function. So notice this clearly, how to use a lambda function. I'll use the keyword lambda, and then I'll pass in a variable x. Now this should consider only those values that are divisible by 3. So I'll write x %3 should be equal to 0, and I'll give my tuple as the variable here. Alright, now we have declared our lambda function. Let's just go ahead and print my new tuple, which is new underscore tup. So here you can see I have my tuple function. Inside the tuple function I'll use my filter function that will filter only those values divisible by 3, and to filter those values I have used my lambda function here and passed in my original tuple, which is my tuple. It's actually my tup, so let's delete the last 2 letters. Let's just go ahead and print this. There you go. You can see we have 12, 18, 9 and 6 are the only numbers that are divisible by 3 from this tuple. Moving to the next question. So our next question is how to create a data frame from a dictionary. Now to create a data frame from a dictionary, you can use the Pandas library and the .dataframe function. Now Pandas is a popular library in Python that is used for data manipulation. So let me show you how you can create an employee dictionary and then convert that into a data frame. Okay, so here on my Jupyter notebook, let me go ahead and import my Pandas library. So I'll write import Pandas as PD, and next let's create my employee dictionary. So I'll write emp, which stands for employee, and within curly braces I'll give my key value pairs. So my first column would be the name of the employee, and let's pass in a list of employee names. I'll write Amy, let's say we have Angela, the third employee's name, let's say we have Samuel, and let Danny be our fourth employee. I'll give a comma. Now the second attribute in our dictionary will be the age of the employee. So my key would be age, and let's create a list of age values. I'm assigning random values to those employee age, 30 and let's say 32. And let's create another variable called city. Here variable refers to the column name of the data frame. Let's say Amy is from New York. Then we have Angela from Chicago. Let's say Samuel is from Boston, and we have Danny from, let's say, Seattle. Okay, so if I run this, I have my employee dictionary created. So if you want to see the dictionary, you can write print and pass the variable name, which is emp here. So this is my dictionary. Now to convert this dictionary into a data frame, you can simply write df, and you can give the Pandas library as PD and use the data frame function. So I'll write data frame, and I'll pass in my dictionary name, which is emp here. Let's run it. Okay, so we have successfully created our data frame. Now let me just print the data frame. I'll write df. There you go. You can see I have a nice table here, which is actually a data frame. Here you can see the indices, and you can see our column names as name, age and city, and these are the values or the rows. Alright. Now let's see the sixth question we have. So the question is, what is the difference between LOC and iloc in Python? Now as data scientists, you would often want to analyze a chunk of data and not all the rows in it. So LOC and iloc functions can help you fetch specific rows and columns from your data frame. LOC function uses row or column labels to select and slice data from a data frame, while iloc uses integer index to select specific rows and columns. Remember, iloc stands for index location. I'll use a car data frame to show how LOC and iloc works. Now on your screens you can see the data frame. So it has a column called brand, which has different brand names such as Ford, there's Hyundai, Tata, Mahindra, there's Maruti, there's Kia Motors. Then we have the year in which the car was manufactured. We have the number of kilometers the car has run. We have the city and the mileage the car gives. So let me first create this data frame on my Jupyter notebook. Okay, so here on my notepad I have my code written to create the data frame, that is car. I'll just copy this code and I'll paste it to this cell. Okay, let me just run it. So I go on top, you can see we have successfully created our car data frame. Now let me go ahead and print this data frame. So I'll write print, in brackets I'll give my data frame as car. Let me run it. Alright, so here is my data frame. Now suppose you want to see the data from second row till the fifth row for brand and city columns, so you can use the LOC function. So I want my data from the second row till the fifth row for brand and city columns. So let me show you how to do that. So first I'll write my data frame name, that is car, and then I'll give my function as LOC, and within brackets I'll give my row index values. So I'll give from 2 to 5, which is second row to fifth row, and I'll give my column names as brand. I'll give a comma, and my second column which I want is city. So here I'm using the labeled based indexing. Let me just run it. There you go. You can see we have the information available for the second row, third row, fourth row and the fifth row. Alright. Similarly, let's see one more example for index location based slicing. So suppose you want to see the data from second, third and fourth row for year, kilometers and city columns. So for that you can use the iloc function. So I want the value for second, third and fourth row, and the columns that I want are years, kilometers and the city column. So for that I'll give my data frame name as car dot, this time I'll use iloc, and within square brackets I'll give my row values and the column values. Now one thing you should notice here is, if you use iloc, Python will exclude the last index, which is the fifth row, and similarly here it will exclude the last index from the column, which is the fourth column. If I run this, you get the desired result. Now let's see another example. Let's say this time I want to print the rows that have mileage less than 25 for brand and city columns. So you can use a print function, and I'll pass in my data frame as car and use LOC. Here I'll give my condition as car, and I want my condition, that is mileage, should be less than 25 and I want the brand name. So I'll use a square bracket and give my brand column, and I also want the city column. Okay, let me close it. If you run this, now these are the brand names Renault, Tata and Kia, which have mileage less than 25. Let me just verify this. You can see all these values are less than 25. Similarly, you can use the iloc function as well. I can write print. I'll give car dot iloc. Within square brackets, I'll give car and my condition column is mileage. Now this should be less than 25. I'll use dot values and then I'll give my column numbers as 0, 2. Let me run it. There you go. The same result, we have got it using iloc function this time. And you can see the columns were 0, 2, which means we wanted the first column, which is brand, and the second column, which was kilometers. Alright. Now moving to our 7th question in the list of questions that we have. The question is, how is list.append different from list.extend? Now list.append adds its arguments as a single element to the end of the list. The length of the list increases by 1 here. And list.extend iterates over its arguments and adds each element to the list. The length of the list increases by the number of elements in its arguments. So let me show you the difference on my Jupyter notebook. Okay, so let's create a list called list1 equal to, I'll create a list, let's say it has some country names like India, then we have USA, and I'll consider one more country, let's say Canada. Okay, now let me print the length of this list also. I'll use the length function for that. Alright, now let me append one more list. So I'll use the append function. I'll write list1 dot append, and within brackets I'll give my new list which has two more country names, let's say France and Spain. Okay, and here let me print list1 and let's also print the length of the list again. I'll use the length function and my list name, which is list1. So just mark we are using append here. Let me run this. There you go. So here you can see my original list had 3 elements, hence the length is 3. Now when I appended this new list which had 2 elements, France and Spain, our size increased by 1 and the length of the new list is 4. Now let me just copy this code and instead of append let me write extend so that we can see the difference between append and extend. I'll just scroll down, run it. Here you can see our original list had 3 elements, but after we extended our list with 2 more elements, the length of the new list became 5. So these are the 5 elements in the list, and here you can see there were total 4 elements in the list when we appended the new list. Okay, now moving to our 8th question. Suppose you have a car dataset which has a mileage column. You need to create a new field called MLG that will accept 2 values. If mileage is less than 25, then the value should be low MLG, and if the mileage is greater than or equal to 25, then the mileage should be high MLG, or the value should be high MLG. Now while analyzing data, data scientists often need to create extra columns in the data frame to add more values that will help you make your data analysis more efficient. So this question is related to one such instance or one such idea. So here you can see my data set. It has the brand name, year, kilometers, city, and the mileage column. Now if mileage is less than 25, I'll add the value low MLG to my new column. Else, if mileage is greater than or equal to 25, I'll add high MLG to my new column. So here you can see my final output. Wherever the mileage is less than 25, it should print low MLG, else it should print high MLG. And now let's do this on my Jupyter notebook. So we'll use lambda functions that we learned earlier to perform this task. I'll write a function, let's say f is equal to, you can call this as a function or a variable. I'll give the keyword lambda and use x as my parameter. Now x should be low MLG if x is less than 25, which is mileage here, else if it's not less than 25, it should return high MLG. Now what I'll do is I'll give my data frame as car and I'll create my new column, that is MLG. Then I'll write equal to car dot, I'll give my column name from the original data frame, which is mileage, and I use my apply function and pass in the variable f. Now let's just print this data frame. If I run it, you can see the output here. We have created a new column which is MLG. You can see our new column name was MLG, and these are the results. So for Renault, Tata and Kia, for the last 3 rows, since the mileage is less than 25, it returned low MLG. For the remaining, it gave us high MLG. Now moving to the 9th question. So this is our next question. We want to create a 4x4 matrix and find the sum of all the diagonal elements in the matrix. Data scientists often work with multiple dimensional arrays or multi-dimensional arrays and matrices to build models. This question is related to an operation on a 4x4 matrix. So first, we need to create an array which will be a numpy array of 4x4 shape, and then we'll see how to calculate the diagonal elements or the sum of the diagonal elements. So I am on my Jupyter notebook. First, let's import the numpy library. So I'll write import numpy or numpy as np. Let me run it. Okay. Now I'll create my 4x4 matrix. So I'll write m is equal to np dot array, and I'll create my 4x4 matrix. Let's say the values are 1, 2, 3, 4 in the first row, and in the second row I'll pass 5, 6, 7, 8. In the third row we'll have 9, 10 and 11, also 12, and finally we'll have 13, 14, 15 and 16 in the fourth row. I'll just run it. Now if I print m, you can see this is a 4x4 matrix. So this is one way of creating a 4x4 matrix, which is a bit tedious and lengthy. Instead of that, you can also use arange function. So if I write m is equal to np dot arange function, and here I'll give my values starting from 1 till 17. So this will actually exclude 17 and take from 1 to 16, and I'll give my shape as 4, 4. Let me print it. There you go. It has printed the exact same matrix that we saw above. Alright. Now to print the diagonal elements, we'll use the diagonal function. So I'll write print m dot diagonal. Let me just run it. So 1, 6, 11 and 16 are my diagonal elements. You can see this matrix. 1, 6, 11 and 16 are my diagonal elements. Now to print the sum of all the diagonal elements, I'll use the sum function. So I'll write m dot diagonal. Along with that, I'll pass my sum function. If I run it, so the sum of 1, 6, 11 and 16 is 34. Okay, so coming to the last question on this interesting session on programming interview questions for data scientists. Our question is, given a vehicle data frame, find the average and maximum mileage of the vehicles using Pandas. So here, data scientists use statistical measures to analyze their data, so it is important to have knowledge of the statistical functions in Python. Here is my vehicle dataset, and for each brand of vehicle, we want to find the average and the maximum mileage. So let me show you how to do it. Okay, so here on the notepad, I have my code written to create the vehicle data frame. I'll just copy it and paste it on this cell. You can see we have the brand column, the year column, kilometers, city, mileage. Here you can see the different brand of vehicles. Let me just create this data frame first, and let me go ahead and print the vehicle data frame. So I'll write vehicle and run it. So here is the data frame. Now I want to find the average and maximum mileage for each of the brands. So for this, we'll use the group by function and the aggregate function that is available in the Pandas library of Python. So let me show you how to do it. I'll give a variable called result, and then I'll use my data frame name as vehicle, followed by the group by function. I'll write group by, and since I want to check for all the brands, so I'll group all the brand of vehicles. Then I'll use an aggregate function which is agg, and within curly braces I'll give my column as mileage. I'll give a colon and pass in mean, which is for average, and I'll use max to find the maximum mileage. Now let's print it. I'll write print. I'll give a message as the average and maximum mileage of vehicles. Let me just print the result. I'll run it. You can see it has resulted in an error. The reason is in vehicle the V is capital. If I run it, there you go. Here you can see on the left we have the brand names. We have Hyundai, there's Maruti and Tata, because those were the only 3 brand of vehicles we had. And for each brand you can see the mean mileage and the maximum mileage. For Maruti it was 26.33 and the maximum mileage is 28. Similarly, you can see for Tata vehicle as well. So that brings us to the end of this live session on programming interview questions for data scientists. I hope you liked it. If you have any queries, then please put them in the chat section or the comment section of the video. Also, we'll be coming up with a live session on SQL interview questions for data scientists soon. Stay tuned for that. Thank you for watching and keep learning.